Okay, hi everyone. Prove that for all positive integers n, we have this equation is true. Okay. So let's give this equation a name, star. So proof. We will use proof by induction to show star is true for all the infinitely many positive integers, for all n, a positive integer. Okay, so the base case is, well, let's take n equals 1. Then what, the left-hand side is add up all the numbers to n, so we just have 1 plus, and then there's nothing more. We're already at n. The left-hand side, or the right-hand side, we have to plug in n equals 1. And sure enough, this actually is true. It's true. So in other words, star is true for n equals 1. And sometimes I like to do two base cases. You don't really need to do a second one, but let's just see it. 1 plus 2 is the left-hand side. And the question is that equal to the right-hand side when n equals 2? And yeah, sure enough, 2 and 2 cancel, and we get 3, and that's 3 is true. Okay, so now the induction step. Okay, so the induction step, we will prove that star true for n implies star is true for n plus 1. Okay, and proof by induction means that, well, if we can prove this, if we can, in other words, prove that having it at some step n, like n equals 10, then that will imply that it's true at the next step, n plus 1, like it's true at n equals 11. So if we can show it's true at n, it'll be, no. If we assume it's true for n and show that that means it's true for the next one, then it's sort of like all the dominoes falling. Like if we have a bunch of dominoes lined up, and we can prove that if we push the first one over, it'll hit the second one. Then what we've proved is that all the dominoes are going to fall. That's basically induction. Okay. So let's assume that it's true for n, and now we have to prove it's true for n plus 1. So really what we're wondering is, if we add up all the numbers up to n plus 1, we're wondering, is this going to be equal to, okay, and now I have to go up here. So when n is n plus 1, now I have to plug n plus 1 there and n plus 1 there. So I'll get n plus 1 times n plus 1 plus 1 over 2. In other words, n plus 1 times n plus 2 over 2. And so if we can, this is what we want to prove, that this equation holds. Okay? And what we're allowed to assume is that the previous equation holds, which means this piece we can rewrite. By assumption, we can rewrite as, well, it's true for n. So this piece right here is equal to this. N times n plus 1 over 2. N times n plus 1 over 2. And we still have the plus n plus 1. Okay, so this piece is equal to that, which is equal to, and now let's multiply by 2 and divide by 2. Okay, I just took this and multiplied by 2 and divided by 2, so it didn't do anything. And then I added with the common denominator. Do you see that? Now, this numerator here has two terms. And let's factor out something from both of them. So let's factor out an n plus 1. What remains from the first term when I factor out n plus 1 is n. What remains from the second term when I factor out n plus 1 is 2. And I still have the denominator. And look at what we have. So that's great. So by induction, we have shown star is true for all n, a positive integer. Okay, so that's proof by induction. You have to show that it holds to begin with. In other words, that you can push down the first domino. And then you have to, if you can prove that a previous domino falling will then make the next domino fall, and you can prove that will always happen, well then you've shown that all the dominoes are going to fall.